All right, on this review sheet that you see here, what, what's on the review sheet will be similar to what's going to be on your exam number 2 on Thursday. Also, uh, there are 15 problems on this review sheet, meaning that there will be 15 problems on the exam. And you will be allowed a one-page sheet of notes with just writing on the front and nothing on the back, okay? And it could be whatever you like on there. It could be uh, probably formulas, some procedures that we've gone over in class that are related to chapter 2, and so on. All right, so we'll start with problem number 1. Okay, let me go and label this. And in problem number 1, you're given 3 different mappings or 3 different diagrams, and you want to determine which diagram represents not a function and explain why. Now, for a relation to be a function like this right here, and by the way, the numbers on the left side is your x, and the numbers on the right side are the y for each one of these, x, y, and then x, y. All right, for it to be a function, you cannot have an x value going to 2 different y values. Okay, so by looking at that, which diagram would not be a function is C. And you can see here that -4 is going to +1 and +3. So you can say here that graph C is not a function. And probably a good reasoning for that would be is that 4 is paired with 1 and 3. That's something that you can write as a reason why mapping C is not a function. Okay, so that's problem number 1. Problem number 2 is using a vertical line test to determine if the graph below represents a function. Okay, so I'm going to draw a graph similar to the one that's on the review sheet. When you use the vertical line test, that is used to determine whether or not that graph is a function. And when you draw a vertical line, if that vertical line crosses the graph in more than one place, then it would not be a function. So based on this, would this be a function if I was to draw the vertical line? No. Okay, and as you're going to see here with this vertical line, it's crossing the graph at 2 different places. So in this case here, this graph is not a function. Okay. All right. Are there any questions about problem number 2? Okay, now problem number 3, and I'll do problem number 3 over here. Here we have a function, f of x is equal to 3x cubed plus 5x squared. And here I want to evaluate f of -4. So basically all we do here is just replace each x in that function with -4. So here we're going to have 3 times, and then x is -4, and that's cube, plus 5 times -4, and that's squared. So here we just simplify the right-hand side. Well, if I have a negative and I cube it, that's going to be negative. So let me bring down the 3 times. Let's see, I know that's going to be negative. 4 cubed is 4 times 4 times 4. That's 64. So I have 3 times -64 plus 5 times If I square a negative, that's going to be positive. So negative 4 squared will be negative 4 times negative 4. That's 16. And then 3 times negative 64, that's going to be negative 192 plus 5 times 16, that's 80, using the order of operations. And then we add negative 192 to 80, you'll end up with negative 112. So the value of that function when x is equal to negative 4, or f of negative 4, will end up being negative 112. All right, are there any questions about problem number 3? All right, number 4, here we got g of x is equal to x squared plus 2x plus 3. And here I want to find out what g of x plus 5 is going to be. So here I'm not looking for a numerical value. I'm looking for a expression after replacing your x with x plus 5. So in this case here, every x in g of x will be replaced with x plus 5. So that means that this x will be x plus 5, and that's going to be squared, plus 2 times the x will be replaced with x plus 5, and then plus 3. And then from here, we just simplify the right-hand side. Now that x plus 5 quantity squared, now I'm going to do that x plus 5 quantity squared on the right-hand side, so that way you can see that x plus 5 is used as a factor twice. So I'll write this as x plus 5 times x plus 5. And from there, I'll use the FOIL method, meaning first term times the first term, x times x. That's x squared. Outer, x times a plus 5 will be plus 5x. The inner, 5 times x plus 5x. And the last times the last, 5 times 5 plus 25. And then combine like terms, so we bring down the x squared. Add 5x and 5x together, you'll get 10x, and then plus 25. So that is what x plus 5 quantity squared will be. X squared plus 10x plus 25. And then that 2 times the quantity x plus 5, I'll just distribute that 2 over the x plus 5. That would mean 2 times x will be plus 2x, plus 2 times the 5 will be plus 10, and then plus 3. And from here, we just combine like terms here. So there's nothing to combine with the x squared, so we bring that down. 10x plus 2x will be a plus 12x. 25 plus 10 plus 3. Add those together, you'll get 38. So this is what g of x plus 5 will end up being. X squared plus 12x plus 38. Okay. Now, are there any questions about problem number 4? Now, problem number 5, here we have this graph of a function. Now, we're going to use that graph to determine the open intervals on which the function is increasing, if any, and open intervals on which the function is decreasing, if any, and the open intervals on which the function is constant, if any. So here, so there are 3 parts here. Part A, the intervals on which the function is increasing. The open intervals on which the function is decreasing. part C, the open intervals in which the function is constant. That is, if any. Okay. Now, usually with a graph like this, I would use a piece of paper and cover the graph up and move that paper from left to right to see where it's increasing or decreasing or constant. So if I move this from left to right, I see that arrow going downwards, so that means this goes on indefinitely to the left, so that means I know I'm going to have negative infinity, but it's going to be increasing up to this point right up here. And the x value, where it reaches its highest point, will have to be -4. So, from negative infinity to -4, that graph will be increasing on that interval. So let me go back here and say that it's increasing on this interval, negative infinity to -4. Okay. And then after -4, once it reaches its highest point, then it starts to decrease and continue to decrease until it reaches its lowest point right here. And its lowest point is at -3. So between -4 and -3, the graph of this function is decreasing. Okay, so under decreasing, which is part B, it's going to be decreasing on this interval, -4 to -3. And these are open intervals, so make sure that you're using only parentheses, not brackets, just parentheses. And then after -3, here's -3, then it starts to increase again. It increases until it reaches its highest point at the x value of -2. So between -3 and -2 is increasing again. So under increasing, which is part A, negative infinity to -4, which is already there, and also we're going to include -3 to -2, because that's the interval where that function is increasing. And then finally, after -2, you can see it starts to decrease continuously from -2 on to infinity, because that arrow shows that this goes on forever. So from -2 to infinity is where the graph is decreasing. And for constant, we can just say none. Constant means that the line has to be a straight line. It's not going up or down, it's just a straight line. And there's no straight line anywhere in that graph. So the answer there would be none for part C. And that's how we list all the intervals on which the function is increasing and decreasing and constant. Are there any questions about number 5? All right, number 6 deals with relative maximum and relative minimum. So here, this is not the best looking graph because the numbers are on the x and y axis kind of bunched up. All right, so here we want to use that graph to find the numbers, if any, at which f has a relative maximum, and what are those relative maxima. And then the B part is the numbers, if any, at which f has a relative minimum, and what are these relative minima. All right, let's start off with the relative maxima, which is part A. So here we're going to be looking for the relative maximum. Let's find out where it occurs, because we're going to be looking for the x value where it occurs. And also we're going to find out what that relative maximum is, relative maximum. All right, so referring to this graph here, your relative maximum is going to be the highest point. And if you look at it, this right here, this point is the highest point on the graph of this function. And we're looking for the x value for where it occurs. So if this is your relative maximum, the x value where it occurs will be at, in this case, now it might be hard to read, but it is at x equal -1. So the relative maximum occurs at x is equal to -1. Now your relative maximum is going to be that y value. So if this is your relative maximum, the y value that is associated with that will have to be 2. So the relative maximum is 2. And it occurs when x is equal to -1. Okay. Are there any questions about part A? Now, part B is going to be x value where the relative minimum occurs. And then we'll find out what that relative minimum is. All right, so now going back to this graph. That would be the lowest point on the graph here. So here we got 2 points that are the lowest point, right here and right here. Let's find those x values where they occur. So this first lowest point right here occurs at x is equal to, in this case, -2. And this point right here occurs on the y-axis, so that means that my x value will have to be 0. So here I got 2 places where the relative minimum occurs, at x equal -2 and x equals 0. All right, now let's find out what that relative minimum is, which is going to be the lowest y value that we have here. The lowest y value for this will have to be, in this case, -2. So your relative minimum is -2. Yes. Okay. That point right there is actually on the y-axis. Okay. Any other questions?
So how do you know, like, when you get
Where it occurs is going to be the x value. The relative maximum or the relative minimum is always the y value. Okay? Any other questions on number 6? Now, problem number 7 is a piecewise function. So here we're given this, f of x is equal to -2x plus 3 if your x value is less than or equal to 4. F of x equals 3x if your x value is greater than 4 and less than or equal to 7, and or 5 if x is greater than 7. Okay, so I'll go ahead and write that. So here, f of x is -2x plus 3. That's if x is less than or equal to 4, or 3x if, let's say 4 is less than x and less than or equal to 7, or 5 if x is greater than 7. So here we're going to find, using that piecewise function, we're going to find out what f of 4 is. Now, that's your x value. That's going to tell you which one of these we need to use. And in this case, since our x value is 4 and x is less than or equal to 4, we have to use the first one, -2x plus 3. So we've got -2 times x, which is, in this case, 4. We'll replace the x with 4 plus 3. So negative 2 times 4 would be negative 8. And negative 8 plus 3 will be negative 5. So the value of that piecewise function when x is equal to 4 will be negative 5. So keep in mind, that's your x value. That will dictate which one you need to use based on those conditions. And then for f of 234, f of 234. Well, the x value is 234, so that's going to tell us which one we need to use here. No? X value is 234. So which one do we need to use here? The first, the second, or the third? The third one. Because that 234 is greater than 7, so that means we have to use just a 5, and there is no value of x. There is no x that we can substitute. So f of 234 would just be equal to 5. Okay? And any x value bigger than 7, if you were to graph that, you're going to end up getting a straight line past 7. All right, any questions on number 7? All right, number 8 deals with a function, and we have to determine whether a function is even or odd or neither. So let's look at number 8. We got f of x is equal to 3x cubed minus 6x plus 1. And I want to determine whether that function is even or odd or neither. And to do that, we always have to replace each x in that function with negative x. All right, so f of negative x will end up being this: 3 times negative x cubed minus 6 times, replace the x with negative x, plus 1. Anytime you cube a negative, that's going to end up being negative. So I know I'm going to have a negative in front of the 3. And then x will be to the third power, so it'll be negative 3x cubed minus 6 times the negative x will be a plus 6x plus 1. Now here, you're going to compare what f of negative x is to what f of x is. Now, for it to be even, you must get the original function that you started off with. For the function to be odd, every single term in the function has to change to the opposite sign. Otherwise, it's neither. In this case, if you look carefully, only the first term changed to the opposite sign, only the second term changed to the opposite sign, but that plus 1 remained the same. This did not change to the opposite sign. So that means that this function will be neither even nor odd. Every single term has to change to the opposite sign. In this case, the plus 1 remained the same. Everything else changed. Yeah.
If it was like instead of x cubed, if it was x squared, would it?
It's going to stay the same. Because when you square negative, it's going to be positive. Any other questions? Okay. Problem number 9 is finding the domain of the function. All right, so here we got f of x is equal to 2x cubed plus 9x squared plus 7x minus 4. The whole thing is divided by x squared plus 4x minus 12. In this case, I have a rational function because I have a numerator and a denominator, and I do have variables in the denominator. So what I need to do here is take what's in the denominator and set that equal to 0 because I want to find out what values of x that would give me a 0 in the denominator. So I'll take x squared plus 4x minus 12 and set that equal to 0. And notice I have a quadratic function here, or quadratic equation, I should say. So here I'm going to factor the left side into two binomials. Let's see if we can. Let's see, x squared breaks up as x, and I need factors of negative 12 that will give me 4x as a middle term. And in this case, it's going to be, I already know what this is. This is going to be 6 and 2. But I got to make that a plus 4x, so one's got to be minus, the other one has to be plus. Well, the larger of these two factors will take the sign of the middle term. So the 6 will be a plus, since that middle term is a plus. The 2 will have to be minus. So I got x plus 6 times x minus 2 is equal to 0. And by the way, if you do 6x and a minus 2x, you would get 4x. Now we're going to set each binomial factor equal to 0. So this means x plus 6 equals 0, or x minus 2 is equal to 0. And for each equation, we'll solve for x. So for the x plus 6 equals 0, if I subtract 6, you're going to get x is equal to negative 6. Or for the x minus 2 is equal to 0. That means x will have to be equal to 2. So at x equal negative 6 and x equal 2, I would get a 0 in the denominator. Now, in the exam, you will be required to give your domain in interval notation. So, if this helps, and this is not necessary, you can draw a number line. Let's see, negative 6 will be here. On the left of 0, 2 will be to the right of 0. As we know, at negative 6 and 2, I will get zeros in the denominator. So I'll use parentheses around negative 6 and parentheses around the 2. Everything to the left of negative 6 will satisfy that function, so I shade to the left. Everything in between negative 6 and 2 would work, so I shade in between, and anything bigger than 2 would satisfy that function, so I shade to the right. So the interval notation for the domain of this rational function would be this. Negative infinity up to negative 6, or from negative 6 to 2, or from 2 on to infinity. Okay. That's how we write the domain of this rational function in interval notation.
So, what looks like the union?
That's a union.
So it's just like,
Yeah.
what is like
This,
the,
this actually means or. Okay.
what is,
That's and. That's what they call the intersection. The upside down U means the and.
so what's the,
Okay. The union is meaning that we're putting all of them together. The intersection, or the and, means what's common in both sets. In both.
like, giving it like the crosses?
Yeah. Where they overlap. Any other questions? Okay, number 10. This time you have a radical function. You have a square root function, to be honest. All right, number 10. Here we got f of x is equal to the square root of 84 minus 6x. And here I want to find the domain of that function. Now, in this case here, we have a square root function. That means I need to find out what values of x that would give me a square root of a positive number. okay, or 0. So I take that 84 minus 6x, which is underneath the radical, set it to be greater than or equal to 0 because only numbers that are positive or 0 would satisfy that square root function. Now I need to get x by itself. So let's move that 84 over to the other side by subtracting 84 on both sides. So this would be negative 6x is greater than or equal to negative 84. Now, if I divide both sides of this inequality by 6, what's going to happen to that greater than or equal to symbol? It switches to less than or equal to. And then negative 84 divided by 6 will be 14. So any x value less than or equal to 14 will satisfy this square root function. Now, of course, you're to give the domain also in interval notation. Say 14 is over here. Now, since it's less than or equal to, that means that 14 must be included. So here I'm going to use a bracket instead of parentheses. Okay? Less than or equal to. If you have an equal to sign underneath that inequality symbol, you have to use bracket. If not, then you use parentheses. Now, notice the inequality symbol points to the left, so that means we shade everything to the left of 14, like this. So the domain of this square root function in interval notation would be this, everything from negative infinity up to 14, and it does include 14, so we use a right bracket at 14. All right, questions on number 10. All right, number 11 is the sum and the difference, well, actually, the algebra functions, I should say, because you're finding the sum, the difference, the product, and the quotient of two functions, f and g. So here in this case, f of x is equal to 2x minus 25, and g of x is equal to 3x plus 7. So in this case here, we're going to find in part A, f plus g of x. F plus g of x. And in this case here, that's the sum of the two functions. So we're just adding f of x to g of x. And of course, f of x is 2x minus 25, and g of x is 3x plus 7. And then we just simply combine like terms here. 2x and 3x will be 5x minus 25 plus 7 would be a minus 18. So the sum of the two functions f and g would just be 5x minus 18. Are there any questions about part A? All right, part B is f minus g of x. So here we're subtracting the two functions here. So this means f of x minus g of x. F of x minus g of x. So here f of x would be 2x minus 25 minus, now g of x has to be put in parentheses because I'm subtracting the entire g of x function, which is 3x plus 7, from f of x. So that's why you see 3x plus 7 in parentheses. Now let's simplify this here. Bring down that 2x minus 25. That minus sign makes a 3x minus 3x. The minus sign makes a plus 7 minus 7. And from here we combine like terms. 2x minus 3x will be a, let's see, negative 1x or just negative x. Minus 25 and a minus 7 would be a minus 32. So the difference of the two functions f and g would be negative x minus 32. All right, any questions about part B? All right, now part C looks like this. Here we're multiplying the two functions here. And I got f times g of x on my on the study sheet, but this means the same thing, fg of x, which simply means f of x multiplied by g of x. So that means here we're multiplying the two functions together. So here f of x is 2x minus 25 times g of x, that's 3x plus 7. So here we just apply the FOIL method to multiply two binomials here. That means the first term times the first term, 2x times 3x, would be 6x squared. 2 times 3 is 6, and x times x will be x squared. The outer would be 2x times that plus 7, which will be a plus 14x. The inner minus 25 times 3x will be a minus 75x. And then minus 25 times that plus 7, well, negative times a plus would be a minus 175. Now if we combine like terms here, bring down the 6x squared because I had nothing to combine with it. 14x minus 75x. If I combine those two, I would get minus 61x. And bring down the minus 175. So that's what f times g of x is. 6x squared minus 61x minus 175. Questions on part C? And then part D is this, f divided by g of x. F divided by g of x. That simply means I'm going to take f of x and divide that by g of x. And in this case, f of x is just simply that 2x minus 25 divided by g of x, that's 3x plus 7. And that would be as far as I can go with that problem, because I'm not going to be able to simplify that by factoring any common factors and dividing them out. So it'd just be 2x minus 25 divided by 3x plus 7 for f divided by g of x, or the quotient of the two functions. All right, are there any questions about problem number 11? And make sure, if nothing else, don't miss out on this one. All right, number 12. And number 12 is the composition of two functions, f and g. And there are two parts to that. So in number 12, we got 5x, f of x equals 5x minus 23, and g of x is equal to 4x plus 1. So in part A, we're going to find the composition of f with g of x. And then the B part is going to be the composition of G with f of x. So let's start with the composition of f with g of x as part A. Now in this case here, this notation also means this, f of g of x, meaning your inside function is g of x, whereas the f of x will be your outside function. Now the inside function is g of x. That means that g of x is that 4x plus 1. So I'm going to replace that with f of, and g of x will be replaced with what is equal to 4x plus 1. So I'm going to be evaluating f of 4x plus 1. Now, of course, f of x is equal to 5x minus 23. That means for every single x in the f of x function, I'm going to replace it with what g of x is equal to. So in this case here, in f of x, that notation, that x will be replaced with what g of x is, 4x plus 1. 5x minus 23, that x will be replaced with what g of x is, 4x plus 1. Let me make that 4x plus 1 look better. Okay. Right side, I'm just going to simplify that. If I distribute the 5 over the 4x plus 1, that means 5 times 4x will be 20x plus 5 times 1, which is 5. Then bring down that minus 23. Let's see, bring down the 20x, and then 5 minus 23 will end up being minus 18. So this is the composition of f with g of x. That's what it's going to be equal to, 20x minus 18. Okay. So that's just the composition of f with g of x, which is part A in this case. Now, B is the composition of g with f of x. Composition of g with f of x. Which means this, g of f of x. So this time, f of x is the inside function, and g of x will be your outside function. And here the inside function is f of x, and f of x is 5x minus 23. So I'm going to replace f of x with what is equal to 5x minus 23. So I'm going to be evaluating g of 5x minus 23. Now, of course, g of x is equal to 4x plus 1. That means every single x in g of x will be substituted with what f of x is. So in the g of x notation, that x will be replaced with what f of x is, 5x minus 23. And in the 4x plus 1, that x will be replaced with what f of x is, 5x minus 23. And now we're going to go ahead and simplify the right side. Distribute the 4 over the 5x minus 23. This means 4 times 5x is 20x. 4 times 23 will be, I believe, 92. And then if I simplify that by combining like terms, bring down the 20x minus 92, and a plus 1 would be a minus 91. So that means here the composition of g with f of x would be 20x minus 91. Are there any questions about part B or any questions about problem number 12, using the composition of functions? All right, problem number 13 on the page. Now here you're given a function that's already been composed. We're going to find out what f of x and g of x are, or start it off with. So here we got f of g of x, that's equal to 5 divided by, let's see, x squared minus 3x plus 6. That quantity is to the 6th power. And here we're going to determine the functions f of x and g of x such that we have the composition of f with g of x being equal to that. All right, so let's find out what f of x was and what g of x was. And keep in mind, when it's like this, your inside function is g of x. So that means, if we were to look at this, we can take that x squared minus 3x plus 6, and that would be the inside function, in this case, g of x. So that means g of x would be that x squared minus 3x plus 6. That would be your inside function, which would mean that f of x, now, since that x squared minus 3x plus 6 was put in place of x in our f of x function, that would mean f of x will have to start off as 5, which is my numerator, divided by, this was put in place of x, so it had to be an x, raised to the 6th power. So f of x had to start off as 5 over x to the 6th. G of x had to start off as x squared minus 3x plus 6. Any questions about problem number 13? Because all we're doing is taking a composed function like this and just breaking it apart to find out what f of x and what g of x was. Problem number 14 is finding the inverse of a function. So let's say we got f of x is equal to 9x plus 23, and I want to find the inverse of that function. Now, back in section 2.7, I gave you a 4-step procedure for finding the inverse of a function if you're given the function itself. So the first step would have to be replace this f of x notation with y. So it'd be y is equal to 9x plus 23. And then the next step would be to interchange x and y. So that means that this y becomes x, and this x becomes y. So it'll be x equal 9y plus 23. And then we solve this equation for y. So that means I need to move that plus 23 over to where the x is by subtracting 23 sides. So that means x minus 23. These are two totally different terms. We can't combine those. We just have to write as x minus 23 is equal to 9y. Now to solve for y, we're multiplying by 9. We divide both sides of this equation by 9. So that means y is equal to x minus 23 over 9. Then the final step would be to replace this y with the f inverse of x notation. So f inverse of x would be x minus 23, and the whole thing divided by 9. Are there any questions about problem number 14? All right, and finally, number 15, you're given a graph of, of so it's going to be a function, by the way. Well, actually, not a function, but it is a graph. But we're going to take that graph to determine if it has an inverse using the horizontal line test. Okay. Here's what the graph looks like, similar to that. Now, the horizontal line test helps us determine whether a graph has an inverse function. And can only cross the graph at one point. If it crosses the graph at more than one point, then there's no inverse for that function. So in this case, would there be an inverse? You're doing the horizontal line test. Yeah, yeah. You can draw the horizontal line anywhere above or below the x-axis. And it's crossing the graph, in this case, at only one place. So this graph has an inverse function. Yeah.
So what happens if it doesn't?
If it doesn't have an inverse function, that means it's not going to be one-to-one, and it's for a graph like this, it's going to has to cross the graph at more than one place. For
First function, would you not be able to do like where it doesn't have an inverse?
does not have an inverse. Does not. Okay. Any other questions? Okay, so that's all I have. That's basically what you'll see on your second exam, covering all of chapter 2. All right, and do make sure that you do have a one-page sheet of notes, and it could be this stuff that I just went over with you all. Uh, Make sure that it's only writing on the front and nothing on the back. Make sure you do bring your own calculator to the exam and something to write with.